my dear student, I'm Mr. Kitwala from Educators. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on the topic of wave for the subtopic of the wave motions. So, my lovely student, as we have tried to explain on the last session, we tried to discuss about the stationary waves, and we can summarize by saying that this stationary waves means that the two progressive waves are having at the same speed, having at the same frequency, but equal amplitude. If they try to travel in the opposite direction and they produce the nodes and also the antinode, hiyo tunaita ni stationary waves my dear. So sometimes tunaita ni standing waves kwa sababu ni wave mbili ambao zimekaa in opposite direction, lakini zinakuwa na amplitude sawa, lakini zina mean at the stationary point. It means the particles they can change, most of them they reach the maximum point, and some of them they still at rest, my lovely students. So today let us try to discuss about the expression for progressive and also the stationary waves motion. Kwa leo tutaenda kuangalia hii expression, how can we express this progressive and also the stationary wave motion. This is what we are going to discuss for our today discussion here. So particles motion and the progressive and also stationary can be considered to perform a simple harmonic motion. So the particles that are found on the progressive and they also on the stationary waves, they should obey, they should undergo the simple harmonic motion. Kwa wale particles ambao wana happen under the progressive and also under the stationary waves, wanakuwa na tabia za kuweza kumove za kuobey ile simple harmonic motion. It means they could move upward and downward. If they reach the maximum point, wanashuka chini. Wakilishi kwenye maximum minimum point, wanakuwa kwa wale particle wanakuwa na tabia hizo. Ndio kitu ambacho tunajaribu kuelezewa hapa, my lovely students. They could undergo the simple harmonic motions. So in this regard, their displacement and velocity can be derived based on the simple harmonic. So on this, as we have been told, my dear student, regard their displacement and also the velocity. Kwa hiyo hapa inakuwa inajikita either kwenye inakuwa inatupatia the formula of displacement and also the formula of the velocity, which we derive this. If they undergo the simple harmonic motion, they could enable us to derive the formula of the velocity and also the displacement, as we have been told, my lovely student here. So let us try to look for Roman A. For Roman A here, we have been told to see the displacement and also the velocity of progressive wave motion. Ndio kitu ambacho tutaenda kukiangalia hapa, how can we derive the formula of the displacement and also the formula of the velocity using the simple harmonic motion. So suppose a particle P is at the original O. Assume that we have the particle P, and this a particle P is at the origin. Kwa kama tuna particle P, yule particle P yupo kwenye origin, as we have been told, my lovely students, yupo kwenye origin, kwenye point 0 ambayo ndo ina imply at the origin, and they are oscillating with harmonic, with simple harmonic. Then they try to oscillate with the simple harmonic, my lovely students. They try to oscillate with simple harmonic motion of frequency F. Kwa watajaribu kumove with the simple harmonic motion of frequency F. So amplitude A and also the angular velocity. If they move under the simple harmonic motion, they form the amplitude, my lovely student, which is expressed by the letter A, and also the angular displacement, which is expressed by the letter W. This is what we have been told, my dear students. And the frequency which is expressed by the letter F, this is what we have been told. Then the displacement y of the particle p at t0 with time t is given. Kwa huyu sasa, huyu ambayo tumeambiwa huyu displacement y ambaye huyu displacement y of the particle p at t0 with time t is given as this. Kwa tabini are given using the expression that we are going to try to observe here, kwamba tuna particle p, yule particle p yupo at the original point ambayo being indicated by the letter 0, my dear student, by the letter O, as we have been told. So we could obtain, we could demonstrate their displacement or their velocity with respectively to the frequency, to the amplitude, and also to the angular velocity. This is what we have been told on our discussion, my lovely students. As we observe here that we was supposed to use a diagram. Kwa tungejaribu kutumia diagram pa tukachora standing waves, alafu tukaonyesha kwamba huyu hapa ni amplitude, alafu huyu hapa anaitwaje displacement, alafu huyu anaitwaje, tungekuwa na uwezo ule wa kuweza kudemonstrate, lakini nimekupeleka moja kwa moja kwenye formula kwa sababu hii concept tulijaribu kuiangalia kwenye topic ya simple harmonic motion, namna ya kuderive the displacement. So if we use a concept, we should obtain that this displacement must be equal to the amplitude times the sin wt. Kwa hiyo tuweza kupata huyu amplitude ambao atabini formed due to the nini, to the simple harmonic motion, it must be expressed as a sin wt, tukiwa tuna maana ya kwamba huyu a anamaanisha amplitude, lakini huyu w anamaanisha the angular velocity, my dear students. So as we have been told, this will be the equation number 80.9. Kwa huyu hapa atakuwa ni equation number 80.9, my lovely students. So after there, this W could give us the relationship between could be expressed as the 2 pi f. Kwa badala ya kutumia huyu W, tutakuja tutasubstitute formula yake ambayo tuliderive kwenye circular motion, ambayo angular velocity might be equals to 2 pi f. Kwa tutasubstitute hapa, mwisho wa siku tutapata kumbe the displacement must be equal to a sin 2 pi f t. This will be the formula obtaining the displacement. So if we wave travel from left to right, imagine those wave they try to move from the left, then they reach into the right side, as we have been told. So their particles p at a displacement x from O will be regarded behind by a phase angle this one. Kwa wale particles, kama sasa tutakuwa na particle na wave ambazo zinakuwa zina uwezo wa kumove kutoka upande wa kushoto zikawa zinaelekea upande wa kulia, tumeambiwa kwamba yule particle p at the distance x from 0, yule particle p at a distance at the distance x from from O will be expressed as a phase angles, as we have been told, my lovely student. This is the phase angle at the symbol as it is indicated here. So after there, let us jump for the now the figure number this figure number 80.7 trying to give us the overview on this derivation of displacement. The waves traverse from left until it reaches to the right side. This is our figure as we have been told, my lovely students. So the figure here represent the displacement for a progressive wave. Kwa ni figure ambayo inaelezea how can we inaelezea the overview of the displacement of the progressive waves. As we have this involve the two axes. We have the horizontal axis and also the vertical axis. Along the vertical axis, we tried to label by use this displacement. We tried to indicate the displacement. While this side on the horizontal or on the baseline, we tried to label as a distance. Kwa upande wa horizontal itakuwa ni distance, upande wa vertical itakuwa ni displacement, my lovely students. So after there, we have been told that. So we observe inside, this is at the center, this is at the original, at the 0 equilibrium position here. Now we observe that the particle here, the wave trying to move, the wave travel from left up to the right, my dear student. Kwa wave zetu tunaziona kabisa kwamba zinavyokuwa zina move kutoka upande wa kushoto kwenda upande wa kulia, as we see, my dear students. But also we have the point up here. Huyu point P yupo kwenye equilibrium position, as we observe, my dear students. And this indicate here the distance from 0 to P is allocated by x, while the distance from this equilibrium position up to this is the displacement from the equilibrium position until it reaches the maximum displacement. Here is labeled by the letter y, as we have been told, my dear students. But the distance between two successive crusts, distance ya successive crest tunaita ni wavelength, as we observe here, distance from this at the original until it reach to the whereby the particle completing the oscillation. Kwa distance ya successive crest mbili tunaita hii tunaita ni wavelength, kama tunapojaribu kuiona, and being recorded allocated by the letter m, my lovely students. So by saying that, let us stop here. We could come and proceed with the next part, my lovely students.